So today we're going to talk about something that I consider very important, supremely important perhaps. Supremely? Seems like an exaggeration, but it's not. It has to do with cognitive impairment, because I know that you know somebody who's cognitively impaired. Does that mean they have dementia or Alzheimer's or just kind of forgetful more than you're comfortable with acknowledging? All those things are possible. I see myself in that. I see certainly my mother in that. Didn't see my dad. He died a little earlier in that. And I now have siblings that are old enough, and I start to see them expressing those signs. The question is, are you going to know anything about how to prevent it or improve it? And whether you want to do anything about it in other people's lives. If they're close to you, you kind of have permission to get involved. If they're not, it's really hard, a sticky wicket, as they say in the UK. I'd like to go through what I would recommend. And it's not just one thing. I'm sorry not to make this simple. It's not going to be really complicated, but I do have to give you a bigger talk to get to a smaller talk. Stay with me. So, 3 steps we are going to talk about to resolve or dramatically improve cognitive impairment. That means, and I'm going to show you that it exists in young people and it obviously exists in older people, but what you can do for that. You ready to go? Good, let's do it. All right, 3 steps to reverse cognitive decline and create a younger brain. I kid you not, regardless of age. The short answer to all of this, so you don't feel I'm stringing you along, is that the 3 things you need to do to reverse cognitive decline are: create an efficient brain energy rescue. We'll talk all about that. Generate precise brain structure, and what that means is your white matter and your gray matter. What is that? What supports that? We're going to get into it. And then you have to maintain optimal neurotransmitters. That specifically really comes down to acetylcholine. How do you make sure you have enough? You don't want to have too much. It's nothing you can bank. And please don't go, I found this thing and I want more of it. I felt so good. I want more of it. Like I want more happiness. It doesn't work that way. Happiness is kind of a neurotransmitter, isn't it? You can have enough of it, but you can't have too much of it. It is what it is. We're going to go through that, and it's going to be both academic, it's going to be empirical, and it's going to be something that you can do. And the whole point of this is to create an impulse in you to take some action on yourself and ideally others, but to know that it's not just an academic issue. Let's get to it. So questions to ask are how to do this, of course. Has this ever been the case ancestrally that we've had in, the cognitive impairment in such a mass scale that we are now experiencing, and is going to get worse on a per capita basis, but also certainly on a increasing population basis? Why is this no longer a personal choice, but a collective imperative? Why do you have to think beyond yourself? Because some human populations are going extinct. Yes, really. They are dying metabolically from adapting a dietary lifestyle based on processed foods. So what are these? It's the Inuits. It's the Pacific Islanders. It is those who are actually Hawaiian Pacific Islanders. They have died earlier and earlier. They've gotten obese. They were of the thrifty cells, if you will, of the thrifty metabolism. That's sort of not quite a cliche, but it's an overgeneralization of what they're experiencing. But they are dying. And the reference of certain human populations going extinct, I don't mean just losing their cultures or losing their language. I mean that their gene pool will dry up because they're eating the wrong foods for their gene. Okay, the disclaimer is this applies to most people, but not to those currently in advanced stages of cognitive decline. So obviously we have healthy brains, right? We can't see our brains, but we can find out a little bit about it. So healthy brains all the way to the point that, and I show a picture here of severe Alzheimer's disease, that's what that stands for, the AD, in which you already have organic destruction. It's hard, you might be able to improve that slightly, but not much. So when you read all these research papers, what they say only effective for early stages of. Only effective for early stages of Alzheimer's or dementia. That's why they call it mild cognitive impairment, MCI. So how do we do this? These are the 3 steps, so you can stop watching right now. But I'm going to go into these 3 steps. Ketosis creates a brain energy rescue. Specifically, brain energy rescue. It's the ability to make ketones and use ketones. It's to be in ketosis or metabolically flexible. That's not everything. That's part of it. That's the foundational part. You really have to have that in place, and you need to do the work to get that in place. Some people come to the ketogenic diet, which was originally just for pediatric epilepsy, as, oh, it's going to be the only thing I have to change. You've changed a big part. You've made a big metabolic change. But there's other things you have to be aware of too, like the quality of food you eat, the other nutrition you're getting that has waned away in our world of eating now. Two is omega-3 and B vitamins, folate, B12, and B6, and I'd throw in B2 as well, generates the gray matter and the white matter. It's the stuff. It's the iron girding of our brain. It's the structure. We need to support that. You don't do that, and you go, I'm just in ketosis. I'm in ketosis. Well, good for you. If you're not doing this other part, it probably won't make a difference for you. And the third is, we'll call it choline, but really it's about nootropics. It's about what can you do to support an optimal neurotransmitter concentration. So we're talking acetylcholine. Absolutely, acetylcholine. And don't go, oh, I'm going to get the buzz. I took this supplement. I got a really good buzz on it. I'm not talking about a buzz. I'm talking about health. I'm talking about helping people that have potentially or currently expressing cognitive impairment. And it's for all ages. Are you 20 or older? It applies to you. Okay, here's how I see this. 3 levels of reversing cognitive decline. The foundation is to create a brain energy rescue, to have some form of the ketogenic diet in your life. In other words, to be blunt, drop your carbs. The degree you need fat in your diet, probably initially a lot, and then it will drop down. But you need to drop the carbs, the processed foods. Second, I call the matrix, which is the gray matter and the white matter. It's the iron girding of your brain. It's the structure. It holds it all together. That needs to be built, it needs to be maintained, and it needs to be replaced on a regular basis. And how do you do that? And the third is maintaining neurotransmitter concentration of the acetylcholine primarily, which then, if you did all these things, you'd have all the neurotransmitters, the dopamine, the serotonin, so on and so forth. But it's the acetylcholine that I'm mostly focusing on. Well, I did part of this before. I want to show you that younger people really are cognitively impaired, unlike they've ever been cognitively impaired before. I did one video before called The New Face of Dementia. I'm going to go a lot further with that now in a different aspect, so it'll overlap, but if you're interested, go to that one, and there's a link right above. So the article one of the studies I want to jump in on, we're going to use young women. I'd like to use young men, but young women are better because they have a thing called menstrual cycle, and that cycle can get easily interrupted when they get metabolically deranged, so to say, out of whack. And so we'll be talking about young women with PCOS. So regional brain glucose hypo, low metabolism in young women with PCOS, polycystic ovarian syndrome. I'm going to jump right into it, and I'm going to say that PCOS group showed, compared to a group of women, the same age matched, that did not have PCOS. So they said, what is the difference here? And they're now looking, what the neat thing was, for the last 20 or 30, if not 100 years, PCOS has been based on, oh, it's a hormonal thing. They have too much testosterone. And that's the problem. We don't know how these women got too much testosterone. Well, we do know how they got too much testosterone. Only now it's coming up to have our priorities correct. Our priorities are that it's glucose, insulin, that drives the hormonal dysregulation. The hormonal dysregulation is a consequence of, it's a sequelae of dysglycemia. Too high, too long of glucose and insulin. Let's get into it. So the PCOS group showed a pattern of low regional glucose uptake, regional, different parts of the brain. It wasn't global, different parts of the brain. They created inversely with HOMA-IR. That's a measurement of insulin resistance. That's the IR in several brain regions which resemble the patterns seen in aging and early Alzheimer's. Isn't that amazing? So young women are getting brains that look like those who are far older and have Alzheimer's. Amazing. So these are the brains. So brain regions with significantly lower glucose uptake. Left hemisphere, right hemisphere. What I want to point out, this is the prefrontal cortex. This is the part that actually controls all your decision making. This is your visual back here, your visual center, and we can go on and on. So suggestion here is there is a direct association between mild insulin resistance and brain glucose hypometabolism. One thing you sort of have to appreciate in studies is they have a very sort of gentle way of coming to a conclusion. They'll present the data, but they don't go, and this is it. They try to back off because they don't want any liability. But this is pretty strong. So independent of overweight or obesity that exists in young adults in their 20s. So it doesn't matter if they're overweight or obese, we're talking about insulin resistance, which there's an overlap with that, of course. Okay, now the need for the elderly. So I'm going to show you there's a need for the young and the old. That was part of the young. Here's for the elderly. This just came out in I got an email on this last week. So 23rd of March, 22, it was authorized. It was funded by the Alzheimer's and Dementia Association, and it was from the Boston University School of Medicine. So pretty homegrown, don't you think? Certainly, I'm from New England and lived in Massachusetts for a while. There you go. So what they did over a period of about 30 or 40 years, I'll just read it to you. The study was, researchers included about 5,000 individuals who were part of the Framingham Heart Study. Framingham is a town in Massachusetts, by the way. That's why it's called that. Participants had an average age of 37 upon enrollment and underwent 9 examinations every 4 years until they were 70. That's a pretty long time, don't you think? Each examination researcher measured HDL, high density lipoprotein, LDL, the good LDL or the good cholesterol, questionable, blood glucose levels, body mass index, BMI, blood pressure, and how many cigarettes they smoked. And so let me tell you the conclusions. They're really pretty interesting. So from the second examination onward, the participants also underwent cognitive assessments to track progression of cognitive decline. Pretty cool, huh? It's actually a pretty reasonable study so far. After analyzing the data, the researchers found an inverse relationship between Alzheimer's disease and HDL measured at the first, second, sixth, and seventh examinations. Let's look at this. So I just put this out here. Here's the 7 examinations every 4 years from 71 to 2001. And they're saying from the second, basically every test after the second one kind of measures because you needed something to have a difference, right? So they started showing, so HDL, high density lipoprotein, we're going to look at some data in a second, was the thing. They said it was inversely. So low HDL was high Alzheimer's. Whoa! The study also linked Alzheimer's to higher triglyceride levels at the first, second, fifth, sixth, and seventh, in other words, 2 through 7, through 36 years of the 40 years. High triglycerides were the problem. Finally, I put a little note up here. This is me. This only took 70 years to be able to say publicly HDL and triglycerides are critical. Okay, meanwhile, high blood glucose was significantly linked to the development of Alzheimer's disease at every exam. So elevated glucose, folks, elevated glucose, elevated insulin resistance, pretty straightforward, like beads on a string. Higher glucose levels in blood are linked to more severe plaques in Alzheimer's brains. So the researchers also found no associations between Alzheimer's and LDL. That's cholesterol. Remember the whole cholesterol theory of heart disease? You can say, oh, that's heart disease, it's not Alzheimer's. Actually, they're the same, pretty much. With cerebral, cardiovascular and cerebrovascular diseases are pretty much identical. Brain, heart. So the whole Ancel Keys guy of the 50s was wrong in his contrived studies. We'll get to that in a second. The researchers also found no association of blood pressure at any examination. Whoa! I'll read that again. No association between LDL, BMI, basal metabolic index, smoking, or blood pressure at any examination. Those are kind of big factors for most diseases. Well, how did we get here? Here's my facetious retelling of the story, which I've already told before. Well, there was this guy, no, he wasn't a doctor, and he had a personal quirk about not sharing all of his data, meaning he left out the parts that didn't support his hypothesis. And yes, that's unethical, but only if you get caught. And everyone believed him. Big food industry corporations, the federal government, the entire developed world post-World War II. And his name was Ancel Keys. So the Ancel Keys diet heart hypothesis was elevated saturated fats, elevates your cholesterol in the diet, elevated cholesterol leads to a heart attack. And I also did this in another video, and here's a link if you want to go into that specifically. And guess what? He was completely wrong. It's a really good video to go into to find out the story on that if you don't know it already. So let's check if their conclusion is correct. An inverse relationship between Alzheimer's and HDL. Alzheimer's is linked to higher triglycerides, and high blood glucose was significantly linked to the development of Alzheimer's disease at every exam. All right. This is just the people that I work with. I have a massive spreadsheet, and what I did, I carved out this little section called Most Common Out of Range, OOR, out of range labs. So it's not the whole thing. This is 25% of one of the 4 panels I do on people. They're nice enough to have done for me, so I get to talk to them, work with them. Here's what they talked about. Triglycerides, HDL, and here's total triglycerides. I didn't put in, forgot to bring forward the LDL, but let's go through this. So what I did, I made this whole list here. On the left is going to be the lowest HDL, right? So the lowest HDL should have the highest association with Alzheimer's. I'm not working with Alzheimer's patients, but what I want to see is how does that correlate with triglycerides? And how does that correlate with a lot of other labs? Are these people who just have problems across the board? So let's look. So the lowest HDL that I've measured out of these, this goes on for a couple pages, was 31. So 31, their triglycerides are 408. So what I want people to be for HDL, the HDL number is above 40. I want them to be 90 or 100. That's the goal I want them to push for because it's doable. And it's dependent on saturated fats, by the way. And there's triglycerides really high. So that's a win. That's correct. Here's other things that I measure. I'm not going to get into that, but here's elevated inflammation. Insulin was 52. That's outrageous. This guy's a full-blown diabetic, clearly insulin resistant. Glucose is 201. Hemoglobin, 1AC is 8.9. Homocysteine's high. And so his HOMA-IR, which is what they measured, that's your insulin resistance, was high. So now we scoot across. Let's just quickly go through to the end of, this is half a page. Now we're up to 46 for HDL. Triglycerides as an average. See how the triglycerides are also coming down, are dropping down. But what I want you to also notice is the total cholesterol is going up. Cholesterol is not anything that's to sneeze about. This particular person actually has low cholesterol. Must be on meds. I can't remember this person. But you see all the other cholesterols are going up. Let's go to the next page. This just continues. We have HDL, 48 goes to 102. What we see is total cholesterol is increasing, and we're finding triglycerides are decreasing, except for this one outlier, they've all decreased. So you have just the opposite. Now we do have somebody who's in 100 for HDL, and their triglycerides are 60. That's perfect. Excellent. For whatever reason, they do have some inflammation, but they have nothing in terms of red. Red are things that are out of range. So when you go back to the last one, you'll see, look at all this red. So onto the left side, there's a lot of red. A lot of things are out of range, to be simple about it. So I would say I agree with their conclusions. Okay, step 1 about changing cognitive decline is ketosis creates a brain energy rescue. What does that mean? How do we know this? Let's look at the younger cognitively impaired. So dysglycemia, back to PCOS, not altered sex hormones, affects cognitive function in polycystic ovarian syndrome. 2019, this is new stuff. Conclusions are findings support the role that glycemic control, not PCOS, in cognitive dysfunction in women of reproductive age. So it's how high their glucose is, how high their insulin is. So the discussion we observed, and this is how they measured them, visuospatial ability in women with PCOS compared to controlled subjects. The link between reduced visual spatial ability and higher levels of hemoglobin 1AC, independent from body weight or PCOS status. That's amazing. Still on step 1, now for the still younger. Okay, another one, effects of ketogenic diet in overweight women with polycystic ovarian syndrome, 2020. It's an Italian study, so just 2 years ago. 14 overweight women with PCOS underwent a ketogenic Mediterranean, what do you expect from Italy, right? Mediterranean diet for 12 weeks, for 3 months. So in 3 months, here's their data. I want to point out, here's the stuff everybody looks at. Did their weight go down? Yes. Did their BMI, basal metabolic index, go down? Yes. Fat body mass went down? Yes. Lean body mass decreased negligibly. Their visceral adipose tissue, their belly fat decreased. Weight circumference decreased. But, here's the point. Pay attention here. This is testosterone. Testosterone is what they say PCOS is all about. People with, women with PCOS have too much testosterone. We got to give them more estrogen. We got to give them testosterone blockers. Totally wrong, 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 wrong. And so here's what it is. The testosterone did go down on a Mediterranean ketogenic diet, and their free testosterone, so there's a difference here, and I'll tell you that, and this is important because this is the key to PCOS, went down even more. But now I'm pointing down here, what is this thing called SHEBAG? It's sex hormone binding globulin. So testosterone, whether you're male or female, goes around your body not in a free form. It's inactive because it's attached to, it's on the bus, I call it. The bus is called sex hormone binding globulin. So it's all over the body, but until it gets off the bus, then it becomes free testosterone. So the problem with PCOS has always been there's been a decrease. The high glucose and high insulin decreases the amount of sex hormone binding globulin, therefore forcing more testosterone off the bus, and therefore it appears to be more free testosterone, but it's not more testosterone. Isn't that interesting? So it's really about sex hormone binding globulin, and you'll notice that the pre and post was it increased. So your sex hormone binding globulin increased, more buses, therefore less free testosterone, therefore more estradiol, estrogen, therefore, and also your DHEA, which is a precursor for hormones in general. Thought you'd find that interesting. So also, this is like what I showed you before, this is what changed for them, not just in terms of these little already measured hormones. Their brain is changing, their prefrontal cortex is coming back, their visual acuity is coming back. So, as we said, that a direct association between insulin resistance and brain glucose hypometabolism has changed. All right, now for the cognitively impaired in the elderly. How do we know this? This is the brain energy gap. So what we did is here's young, healthy old, mild cognitive impairment taking 30 grams a day of MCT oil, medium chain triglycerides, we'll get to that later, Alzheimer's disease with exercise, Alzheimer's disease with MCT oil. So the orange is ketones, and the blue is glucose, and this is what your brain needs. Here's 100% at the top of it. So this is young, healthy, is mostly fed by glucose, we know that, right? But they also fed somewhat the brain on ketones. Some part of the brains require ketones, so it's always happening. So now we have healthy old, the glucose has dropped down and the insulin's dropped down, but we're still okay. We're still in a functioning, you wouldn't know, there's no symptoms and so on. So now we're into mild cognitive impairment. Why is that? We've now dropped below the level. There's not enough energy for the brain, whether it's ketones or glucose. And so here we have now mild cognitive impairment, but we boosted their ketones. Notice that the blue is still the same, but their ketones went up. That restored them. They feel, wow, I'm normal again. They still have the gap of being older. That just happens there. But they're now feeling normal. Now we have Alzheimer's disease, which is now even lower on both. So they're just in the gap and they clearly are showing. So if you're below here, you're showing symptoms of cognitive impairment and Alzheimer's and dementia. So now you take somebody with Alzheimer's and they go to exercise, what happens? Their glucose increases and their ketones increase, but mostly it's the glucose. And what happens when you exercise, you increase your cortisol, which increases your own production of glucose, so that brings up the base, okay? Alzheimer's disease, again, Alzheimer's with MCT oil. So the next one should have been Alzheimer's with MCT oil and exercise. You probably would have been brought back to cognitively normal. That's amazing. That is amazing. So we would qualify that and say in the early stages of, but that's still amazing. And this just gives you the numbers of the deficit that they had. So that's the brain energy gap, right? So this white thing here, right? If there's white space, that's the brain energy gap. Here they are fine. The brain energy gap is, this is what they're measuring actually. So down from the top, but here's where you start showing symptoms. So another look at this. So basically this is Alzheimer's disease and MCI, mild cognitive impairment, glucose. Here's MCI this way, here's Alzheimer's disease this way. This is, as you can see, the brain is impaired, so it can't take up as much glucose. And in Alzheimer's, they can't take up much glucose at all. But here's now, we find in a control that, I believe one is placebo, but we're seeing control shows normal both sides. And here we have MCI. We're now starting to show signs of glucose not keeping up. Sorry, this is measuring ketones. And what we're showing is in Alzheimer's, they have actually an increased ability to take in ketones. So that's amazing. So they have a decreased ability to take in glucose as you go into mild cognitive impairment. And the reason that is real straightforward. Is because they live a life of high glucose, which drives high insulin. High insulin blocks a lot of receptors to taking in more glucose. So they actually can't take in more glucose. It's trying to normalize it. And then when they don't have enough glucose and they don't have enough receptors, they're very low on glucose. And that's where they start showing symptomology of being cognitively impaired in dementia. But when you bring in ketones now, that starts to make a big difference. So when do we intervene? It's basically the sooner the better, right? We've seen that young people get it and old people get it. So I would consider being aware of dropping the carbs, consider ketones. We'll get into this, but this is how it looks. So what you have is, without symptoms, brain glucose hypometabolism goes on for a while to the point that it gets to be too far and starts to affect brain function. That's where you start to see symptoms. So it's a vicious cycle. Low energy, gradual brain exhaustion, and Alzheimer's disease. Cognitive symptoms start showing up, and that's how it goes. Feeds into itself. So brain energy rescue, emerging therapeutic concept for neurodegenerative disorders of aging. This is 2020. So this is about using ketones to make up that gap. We should also throw in exercise to make up that gap. Okay, so here's another more technical way of saying the same thing, is that these are all the predispositions. We have, if you're over 60, there's a chance greater risk of being cognitively impaired. If you're insulin resistant, over 25, greater risk of being cognitively impaired. You have a family history, ApoE44, presenilin mutation if you're over 30, and ApoE44 if you're over 30. It's not a certainty, it's just something that you can address. Now you're learning the tools to do that. So what you're having is, here's a brain energy gap, and you're not getting enough energy. What happens is that it goes on for a while, and then you start to impair yourself. Mitochondrial dysfunction, axonal, that's part of your nerves. Loss of glia, these are different nerves that are now starting to break down. Cell death, brain atrophy, plaques and tangles. But this part is where you, between the symptoms down here and the symptomless, but you're still hypo glucose, hypo energy, this is where the rescue takes place. This is where you can intervene. And it looks like this again: healthy young adults, cognitive, people with MCI, and people with Alzheimer's. You can see pretty straightforward as it goes down. How to implement brain energy rescue. Glucose contributes to about 95% of total brain fuel in healthy young adults. Ketones about 5%, and that's what we saw for those diagrams. Brain glucose uptake is decreased about 9% in older adults. So whether you're healthy or not, it's still decreased. So as you get older, you need to be more aware. You need to be more aware of what you need to take care of yourself, believe it or not. It's decreased about 12% in people who are mild with MCI. It's also decreased about 18, almost 20% across the board with mild to moderate Alzheimer's. The magnitude of the brain energy gap is the difference between total brain fuel, glucose and ketones, between young healthy adults, like the perfect little box there that we saw, and mild to moderate Alzheimer's disease. So this is the target. That difference is what we're trying to make up. We're trying to make it up with ketones, and if possible, with glucose. How do we do that? We just said your glucose damage. Well, that's where the exercise part comes in. This is the brain ketone uptake was positively related to cognitive improvement. So I'm trying to prove this to you. Here's the name of the study. A ketogenic drink improves brain energy and some measures of cognition in mild cognitive impairment, 2019, not that long ago. Unlike for glucose, the uptake of the brain's main alternative fuel, ketones, remain normal in mild cognitive impairment, MCI. Ketogenic MCTs are kind of redundant. He's calling them in this particular study KMCTs. Meaning C8 MCT oil, which is caprylic acid triglyceride, which is MCT oils are C8 or C10. They're either made of 10 carbons or 8 carbons, and the one that's C8 is very ketogenic. Could improve cognition in mild cognitively impaired by providing the brain with more fuel. What they did, 52 people with MCI were blindly randomized, and they had 30 grams a day of MCI drink, meaning C8, or a placebo, and the brain ketone and glucose metabolism quantified by positron PET scan. So they looked at the glucose uptake, they looked at the ketone uptake, and they could see that. Those are the scans we just saw. And cognitive performance, that's charting. Hey, how you doing? Can you count backwards by 7 and so on and so forth? Were assessed at the baseline, and 6 months later. Results, brain ketone metabolism. So they've been doing this for 6 months. Increased by 230% for subjects on the MCT. Wow. And that was a blinded study, whereas brain glucose uptake remained unchanged. Measures of episodic memory, language, executive function, remember prefrontal cortex, processing speed increased. That's amazing. That's amazing. That's just on C8. So a dose of C8, 30 grams a day, taken for 6 months, bypassed a significant part of the brain glucose deficit and improved several cognitive outcomes in MCI. 1 tablespoon, basically. And here's what that looks like. Here's pre-ketogenic diet, so to say, and here's post. That's looking at your ketones uptake. That's dramatic. And here's another little chart, not going to really get into it, but it's saying, so what is the ideal? This is all work we've been talking about, actually. It was from Dr. Stephen Kinane up at Sherbrooke University. By the way, I did an interview, a 3-part interview with him on the podcast a couple of years ago. You might want to listen to that, about some of this work, actually. And what it shows is that if you supply the ketones, as your plasma ketones increases, so does it become an increase in that brain fuel. It's strictly by concentration in the blood. Okay, improvement is real. Here is basically the beneficial trial, cognitive outcomes, 6 months on MCT and mild cognitive impairment. What happened? Those on MCT versus placebo increased episodic memory, a brief visual spatial memory test, trail making test, scoop color, whatever, all these different tests, they improved, but the others didn't. That's amazing. And that was funded by Alzheimer's Association USA. Relationship between brain ketone uptake and cognition in mild cognitive impairment. Here we go. Change in brain ketone uptake goes this way, and performance goes that way, and there's the line. Similar positive correlations on several other cognitive tests. It's pretty dramatic. I just want to say there's other studies out there. You can study yourself to death, but you might want to come back to this particular page and look at some of these. And there's a great video, and I've listened to Mary Newport talk and most of these speakers to watch her presentation, listen to what she has to say. And here's what I want to end on. It's the last study that came out just a couple months ago, in February 14th, on Valentine's Day, from Drexel University in Philadelphia. What they did a global summary of all the studies that are out there. And really, this is perhaps the most precise and comprehensive study to date. Glucose is the core source of bioenergy in the body. However, glucose brain metabolism could be affected in cells, of aging cells, due to disease or development. Ketone bodies are a deficient alternative fuel that could compensate for the deficient glycolytic metabolism, glucose metabolism. There you go. And what I wanted to get to, it says MCT ketogenic effects on cognitive brain seems to be reproduced in multiple studies. MCT could be superior to ketogenic diet in terms of long-term compliance, especially in those with cognitive impairment who may need to maintain a steady state of ketosis. However, listen to this. However, everybody thinks, oh, MCT oil, it's going to change my life. I'm saying, on the big picture, it's just one rung we've talked about. So when MCT is not combined with a diet, you just don't drink this, it'll be tough on your stomach. Not combined with a diet such as ketogenic diet, it can only drive ketogenesis for a few hours. I would say even less than that. The existing evidence of using MCT supplementation to support cognitive functioning in those experiencing cognitive decline is promising. And here's the implications of physiological ketosis in the cognitive brain. It's huge, and it's written in layman words, as I've just read to you for the most part. This is a product we used to sell on Amazon. I've been doing a podcast called The Keto Naturopath for over 4 years, and certainly the YouTubes now. But this is what got this. We started this in 2015, late 2015. It's no longer available, so I'm not trying to pitch you. But this was the only product ever available that was from sustainably sourced palm oil. And that's what that insignia. You have to go through a lot to get that, by the way, those certifications and those inspections to your manufacturing. So the problem is, marketing is you can say what your product is and you don't have to verify it anymore. So why buy the expensive stuff? So why I'm ending here just for now, because I've talked a lot and I haven't gotten to the other 2 rungs, which I'm going to put together in the next video. Till then, bye-bye. I just want to say, if this is something you're really interested in, as I am, you might be really interested in following some of these videos. Take care. Till next time.